Welcome to the presentation for solid edge simulation. Through the next 20 minutes, I intend to give you a brief overview of the various simulation offerings for solid edge, which can be used by designers as well as analysts. So why use simulation tools when a product can be physically tested? Introducing simulation to the design cycle does lengthen the design time, with the extra analysis that are run and investigated during this time. However, the real value of simulation is that it drastically reduces the amount of physical testing that has to be performed to validate the design. This represents a huge savings of time and money and far outweighs the increased design time overhead. Overall, with a much shorter design process, more time is available to allow design variations to be investigated, which promotes innovation. Simulation is no longer just a performance validation tool. But simulation is becoming an organic part of the product development process throughout concept and design. Simulation is helping designers create better, more robust designs earlier in the development process, while also speeding the overall time it takes to release a design, meaning faster time to the market. Solid edge simulation solutions are aligned with Solid edge portfolio characteristics in providing powerful, comprehensive, and accessible solutions. The specific solutions we will discuss today are as follows: solid edge simulation, solid edge generative design, SimCenter Flow Master for solid edge, SimCenter Flow EFD for solid edge, and we'll finish off with VMAP. These solutions are based on Siemens SimCenter technology. Solid edge includes capabilities for several different types of simulation and analysis. These includes capability for structural and vibration analysis, kinematic and dynamic motion, product optimization, fluid flow and thermal analysis, 1D fluid flow analysis in complex piping system, and generative design. We include generative design in this presentation because this relatively new design process is based on iterations of structural finite element analysis. Here are a few examples of the types of analysis you can perform on industrial equipment using solid edge FEA simulation. As you can see, we support different type of analysis, starting with analyzing the stresses in heavily loaded components, finding out the factor of safety in a beam using von Mises stress, analyzing natural frequency of a pump and motor, analyzing buckling in a supporting frame, generative design of a component where lightweight is critical, and a new capability that includes analyzing the stress due to hydrostatic pressure in a storage tank. Let's look in more detail at our solution for analyzing structural performance challenges. Talking about the challenges, we need to optimize product designs before manufacturing. How we can help here? We provide integrated structural analysis tools including stress, vibration, buckling, thermal analysis, and optimization. Let me talk about a few benefits that you get. Significant drop in costs and time to delivery as designers optimize components, identify and resolve problems before manufacturing, minimizing the cost and time required to build physical prototypes. Let's look in more detail at our solution for analyzing kinematic and dynamic behaviors, how connected parts move in relation to each other, and what time cycles and accelerations they have. First, let's talk about the challenges. The need to optimize kinematic and dynamic performance being the main challenge. How we can help? By providing you a solution which integrates motion analysis, calculation of forces and transferring them to solid edge simulation. Simulate all aspects of motion and understand the true dynamic function of a design before producing or assembling physical hardware. Here are few benefits. Observing significant drop in cost and time to delivery as engineers optimize kinematic and dynamic behavior. Solid edge integrated motion analysis benefits are continued on this page. We enable engineers to investigate assembly performance earlier in the development process by quickly converting a CAD assembly to a functional motion model. We gain insight into product performance by animating, graphing, and comparing reactions, velocities, and accelerations. We perform structural analysis through direct load transfer to solid edge simulation while maintaining full associativity with the CAD model. Let's talk about the integrated generative design. We look more into detail at our solution for topology optimization. This is an integrated solution within Solid Edge. Let's talk about a few challenges. First one is to take the advantage of new design and manufacturing technologies. Secondly, optimize designs for strength, weight, and material use. How we can help? The solution that we provide helps you to apply software and computing power to create the design that best meets the requirements. Use the latest topology optimization technology for fast and accurate design optimization. A couple of benefits have been listed. Firstly, fast design of optimized and lightweight components. Secondly, create mesh-based solid models with smooth surfaces that are ready for manufacturing. Let's now look in more detail at our solution for analysis of fluid flow in complex piping systems. Our capabilities in this area are included in SimCenter FlowMaster for Solid Edge. Let's talk about the challenges here. The need to understand and optimize fluid flow in very complex piping systems. How we can help here? By providing simulating pressure surge, by providing the ability to simulate pressure surge, temperature, and fluid flow rates system-wide. Tightly coupled co-simulation workflow that enables a 3D CFD model in SimCenter Flow EFD to be considered as a part of a 1D CFD SimCenter FlowMaster network. Let's talk about a couple of benefits that you get. We can conduct what-if analysis for complex systems. We can understand how design alterations, component sizing, selection, and operating conditions affect system performance accurately and quickly. Next, let's see SimCenter Flow EFD for Solid Edge, a full-featured 3D computational fluid dynamics CFD analysis solution, which enables design engineers to work directly on their CAD models to prepare and evaluate CFD simulations of fluid flow and heat transfer. Flow EFD is an award-winning MCAD embedded CFD simulation tool for easy, fast, robust, and accurate fluid flow and heat transfer analysis inside Siemens Solid Edge. Fully embedded in the design environment and with its unique automation technologies, Flow EFD helps engineers to both front-load CFD and carry out parametric studies throughout the complete manufacturing processes. Front-loading here refers to the practice of moving CFD simulation early into the design process, where it can help engineers examine trends and eliminate fewer desirable options, as well as reduce overall simulation workflow time by as much as 75%. Let's look at some of the key capabilities. It provides fluid flow and heat transfer simulation with easy-to-use wizards for guided model setup. The direct integration with Solid Edge eliminates the need for geometry preparation and automates generation of fluid regions. It comes with smart cell technology for automatic meshing of fluid and solid regions. It provides accurate and robust solver technology, what-if simulations to identify optimum design. And here are some examples you see on screen of the different analysis types supported by Flow EFD. SimCenter Flow EFD offers flow solutions to a wide range of industries. To name a few, we have automotive and transportation, aerospace and defense, consumer products and retail, electronics and semiconductors, energy and utilities, industrial machinery, marine, and medical device industries. Let's talk about Flow EFD's range of CFD physics functionalities. The exhaustive physics range of functionalities and capabilities include fluid flow along with heat transfer, real gas flows, Newtonian as well as non-Newtonian flows, compressible and incompressible liquids, free surface flows, rotating flows, radiation and optical effects, condensation, steam and humidity, water films, surface icing and de-icing, cavitation, Joule heating, aerothermal heating, hypersonic, and particle tracking. You can also export the CFD results into the structural FEA analysis to take into consideration the flow effects on the structure. Let's see a case study of how radio nor communications benefited by using our solution. The products that they make are broadband radio communications equipment. Let's see first of all their challenges. The equipment must have optimized aerodynamic performance. They need to be accurate force calculations. The need to minimize size of equipment while maintaining performance. The solutions that we offer: solid edge for 3D product design and packaging of complex electronics in small enclosures. SimCenter Flow EFD for solid edge to ensure optimum aerodynamic performance of aircraft mounted equipment. Here are a few benefits they got. Getting answers faster than before. Acquire knowledge about the critical points. Easier, faster, and more accurate simulations. Now let's see a brief introduction to SimCenter FEMAP. SimCenter FEMAP is available as a CAD independent and solver independent solution for simulation. An upgrade path is available for solid edge users to SimCenter FEMAP. FEMAP has a tight integration with the NX Nastranq solver and covers a wide range of analysis types, including linear and nonlinear solutions. It also provides optimization, heat transfer, rotor dynamics, and aeroelasticity. In addition, FEMAP is widely used in the aerospace, defense, marine industries, particularly for airframe loads and stress analysis. Space vehicle stress and dynamics is also another application. Analysis of ship hull and the offshore platforms is another. The starting point of FE model creation is generally the CAD model, and FEMAP has some extensive functionalities to remove problematic entities and CAD model cleanup tools. FEMAP lends itself to a mesh-centric approach to FE modeling and has in-depth tools for mesh creation and editing. And it can work well with orphan meshes for FE model reuse. For plate and beam modeling, visualization tools are important to let you see how the elements appear with plate thicknesses, beam sections, and offsets, etc. Post-processing and results viewing are also strong FEMAP capabilities, along with the ability to customize workflows to streamline the simulation processes. FEMAP can be launched from within the Solid Edge interface. As FEMAP is launched automatically, the CAD model, as in this case, the Solid Edge assembly, is completely transferred into FEMAP automatically. Another way in which data can be transferred from Solid Edge to FEMAP is to save it as a FEMAP model file. All the geometry, loads, and constraints are transferred. You can then open the model in FEMAP to perform advanced analysis. We will not delve too much into details of FEMAP as this topic commands a separate session. Let's end this session with a FEMAP case study. Here is a case study about how Quest Aircraft overcame their challenge of design and certification of a new aircraft. Their key to success was the use of FEMAP with NX Nastranq. which was easy to learn and use. The results they observed were reduced physical testing and development costs. Time for part validation reduced by a factor of 4. They achieved their FAA certification within 7 months. Here, FAA stands for Federal Aviation Administration. Thank you for giving your time for this short and brief presentation. If you have any queries, please feel free to reach out to me or any of my Siemens partners for a detailed session. Over to you, Anand, for the next presentation.